Question number 5. Figure number 6 shows solid ice on car's rear window. The glass window contains an electrical heating element. 5.1. Use the particle model in figure number 7 to describe how the heating element causes the arrangement of ice particles to change as the ice melts. This question is from the topic of density of material, energy transfer in everyday appliance, and it is an AO2 question. The student need to use the figure number 7. The arrangement of the particles in solid ice is closely packed particles. There is a strong force of attraction is present between them. When the heating element give the heat to the solid ice, the particles in the solid ice they start moving away from each other due to increase in internal energy. As a result, the solid ice changes into the liquid water. Let's see the model answer. The particles in solid ice are held together in a fixed regular arrangement as it is shown in figure number 7 by a strong force of attraction between them. Therefore, the particles vibrate at their position in solid. When the current flows through the wire or the heating element, it gets hotter due to the resistance of the element. It increases the internal energy of the particles in the ice, and the vibration of the particles increases. If the vibration of the particles is fast enough to break the intermolecular forces between the particles, then the arrangement of the particles will get disturbed in solid ice, and the solid ice changes from solid state into the liquid state, means water, and the particles are free to move in the liquid water. 5.2 is an AO3 question. A car manufacturer tests different heating elements by measuring how long it takes ice to melt. During the test, some variables must be controlled. This question is from the topic of density of material. Identify two control variables in the car manufacturer's test. The variables which are kept constant during the investigation, they are called control variables. If you see, different options are given and we need to pick two boxes. The color of the car has no impact on melting of ice. The size of the car has no impact on melting of ice. The time taken for the ice to melt, that is a dependent variable. The variables which are remain kept constant in the investigation, first one is that is the current given to the heating element. It is kept constant for all the different types of elements. So first option is the current in the heating element. The second correct option is the amount of the ice used for the experiment or during the investigation. Some of the energy supplied by the heater causes the ice to melt without the temperature of the ice increasing, which is the key information. 5.3 is an AO1 question, and this question is from the topic of specific latent heat. What is the name given to this energy supplied by the heater? Tick one box. Because the ice is melting, so it is not latent heat of freezing. We know that the ice is melting, it is not converting into vapors forms, therefore it is not latent heat of vaporization. The correct answer is the latent heat of fusion. And student must know the definition of specific latent heat of fusion. 5.4 is an AO2 question in which we need to find the efficiency. When the heater is supplied with 120 joules of energy per second, the internal energy of the ice increases by 45 joules each second. So we can see that that is energy given to the heater and that is the energy given by the heater or the output value. Use the equation to calculate the efficiency of the heater. So we know that the input energy is 120 joules and the output energy is 45 joules, and we need to find the efficiency. We need to substitute these values in our equation and we need to use the calculator and we get the answer 0.375. But if you look in our question, we need to give the answer up to 2 decimal places. So the first 2 decimal places are 0.37, which is already mentioned. Next to 7 is 5, so we need to round our figure, so it becomes 0.38.